Hello student, welcome back to the session. We were talking about Boolean algebra in the last session. Let us continue with that and the logical operations. We had learnt about the NOT operation. Now let us go for the AND operation. Now what is this AND operation? As we had said earlier, it is denoted by the dot symbol or the logical, also known as a logical multiplication. This AND operator is a binary, like it operates on two or more operands. So it takes two or more input variables and generates the output. We'll stop at this now. Generates the output. So what is the logic in this is, let us just assume you have two variables A and B. Okay, these are the two variables. So what is the operation that is being performed? Let us learn in the form of a truth table. So as we said, truth table where you have all the possible operations. So you have A and you have B, and the operation is represented by A dot B. Okay, so the values depend. You have two variables. What are the possible combinations that you can have in A and B? And also you have learned that we have to use, one of the rules is variables can have only one value, that is either binary 1 or binary 0. So what are the possible combinations that you can have for A and B? If A is 0, B can also be 0. A can be 0, B can be 1. A can be 1, B can be 0. A can be 1, B can be 1 also. So these are the possible combinations. That is, A means false, 1 means true. Now, what is 0 into 0? 0 into 0 is 0. You have learned about the logical addition and logical multiplication in the last year session, right? 0 into 0 is 0. 0 plus 1 is 1. All those things you have learned, right? So 0 into 0 is 0. That is A into B. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. So this is your high output. You will have a high output only when both the values of the input are high. This is the logic that is followed in the AND operation. Okay, only if both the inputs are high, the output will also be high. If one input is low, the other input is low, output is low. One input is low, one is high, output is low. One is high, one is low, output is low. If both are high, then it is high. This is the logic that is followed in the AND operation. In the same way, we have the OR operation also. So again, this definition also remains the same. It takes two or more input variables and generates the output. Let us just go with the truth table. So as we have learned, the ORing is represented between two or more variables with the plus symbol. So A plus B. And again, you have the different values for A. 0 and 0, 0 and 1, 1 and 0, 1 and 1. Okay, so what is 0 plus 0? 0. 0 plus 1 will be 1. 1 plus 0 is 1. One thing that you have to remember here is, in the binary addition we had learned that 1 plus 1 is 0 with a carry of 1. We are not following that rule here. We are saying 1 plus 1 is 1. Okay, so the output is 1 if any of the inputs is 1. High. If you want to go into detail now, for example, we have one statement. Let us say A, orange is a fruit, right? orange is a fruit. And one more statement, that orange is green in color. Okay, true statement. Now let us just have a glance at the AND operation first. So, and in AND operation, as we said, only if both the inputs are high, the output will be high. That is, if both the inputs are true, A and B. And you are supposed to join the two statements, that is using your AND. Orange is a fruit and it is green in color. Is it true? Yes. So A is also true and B is also true. So the result is true. Now if we change the statement to okay, we say A statement is orange is a fruit. Is it true? Yes, it is true. And the B is orange is, what can we say, brown in color. Is it true? No, it is false. So A dot B, that is A is true, that means 1. This is, sorry, this is A is 1 and this is 0. 1 into 0. 1 into 0 will be 0. Okay, so this is how your system or your AND operation works. 1 into 0 is 0. In the same way, if you are going for the OR operation, we have the two statements, right? The OR operation, this is fruit, true, this is also true. 1 plus 1 is 1. Yes, true. And if you go for this statement, A plus B, orange is a fruit, 1. Orange is brown in color, 0. 1 plus 0 is again 1. True. That means that here both the statements has to be true. Whereas in OR operation, if any one is true, then it is true. This is your OR operation. If you are going to represent it in Venn diagrams, you know the Venn diagrams now, right? How are you going to represent the operations in using Venn diagram? So you have two circles, right? This is your A and this is your B. This is how you are going to represent your AND operation. Okay, if you go for your OR operation, then you say A, B, everything is colored. And if you go for your NOT operation, this is your A, this will be your A bar. Okay, so this is how you are going to represent your operations using Venn diagrams. Now, the next part, as we said, we talked about the conditions, rules of Boolean algebra, right? And these rules of Boolean algebra, or the fundamental conditions of Boolean algebra, is also known as the Boolean postulates. Let us learn about this now. This is very important. The fundamental conditions or rules of Boolean algebra is called Boolean postulates. The fundamental conditions or rules of Boolean algebra is called Boolean postulates. And these Boolean postulates are used for designing, as we said, the logical functions such as your AND, OR and NOT. the different Boolean, let us know about the different Boolean postulates. As we have said earlier, this is very important for 5-mark questions also. So what is the first rule or the condition of Boolean postulates? If x, we can either say in the terms of a and b or x or y, any variables. If x is not equal to 0, then x will be 1, because there are only two values. X can have only two values. It can either be 0 or 1, right? So if x is not equal to 0, then x is 1. If x is not equal to 1, then x will be 0. And the next postulate is about the AND relations. This is also known as your logical multiplication. Okay, so now we have already seen the truth table. The same thing you are going to apply here. 0 into 0 is 0. We are talking about two variables, so we are using only two, a and b. So 0 into 1 will be 0. 1 into 0 will be 0. 1 into 1 will be 1. This is your AND relations. And the next postulate is about the OR relations. This is known as your logical addition. Okay, so 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. And the next is your complement rules. That is, complement means the opposite. Complement of 0 is 1. That is, 0 bar means 1. Then again, complement of 1 is 0. That is, 1 bar will be 0. These are the basic postulates that we have in Boolean algebra. And the next topic is the principle of duality. Duality means double, the opposite natures. Okay, so the dual forms is used to get one form from the other form. We say that in the principle of duality, we state that we can start with one relation and we can get another relation. That is, what we do in duality is each OR sign, that is plus symbol, is replaced with its complement, or is it opposite, is replaced with an AND sign. What is the AND sign? The dot. Wherever you have plus, you change it to into or to AND. And then again the opposite, each AND sign, that is dot, is replaced with an OR sign, that is plus. Okay, and next, each 0 is replaced with 1 and 1 with 0 in a Boolean expression. Now this is what you mean by a Boolean principle of duality. For example, you have, this is the example, you have x plus y into z bar equals 0. X is a variable. So now what are you going to do? You are changing plus into plus, 0 to 1. Okay, so x into y plus z bar equals 1. This is your dual expression. Okay, so as we said earlier, you can start with one relation and you can get the another relation. Now for example, you say 0 into 0 equals 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. This is your AND operation, right? If you are going to do the dual, then it will be the opposite, as we said. 0 is changed to 1, 1 to 0, AND to or to AND. So 0 to 1, into is changed to plus, 0 to 1 equals 0 is 1. And again this 0 becomes 1, dot becomes plus, 1 becomes 0 equals 0 becomes 1. And again 1 becomes 0, dot becomes plus, 0 becomes 1 equals 0 becomes 1. And again in this 1 becomes 0, dot becomes plus, 1 becomes 0 equals 1 becomes 0. So what does this represent? Your OR operation. You started with AND. If you have a dual, it becomes your OR. So this is your principle of duality. Starting from one relation, you can get another relation. Okay, let us stop this session now here, and in the next session let us talk about the Boolean theorems. Again, that's an important part in this chapter. Thank you.